Hello, TSConf and greetings from Berlin. My name is Tim and I'm working as a TypeScript engineer for a database tooling company called Prisma. So, I am talking about our journey today that we had with the TypeScript compiler, concretely how we pushed the compiler to the limit in terms of quantity of types, but also complexity of types. It's February 2019. At Prisma, we are thinking about how can we make access to databases as easy as possible. And we are mostly focusing on Node.js and TypeScript, so we have been thinking about how can we make the API as awesome as possible. So we have just thought about, okay, what would be the dream API? What would be the optimal API in order to access a database? So something we thought about is some kind of ORM API where you get a CRUD API with create, read, update, delete, and you can, for example, get all the users. And similar to a GraphQL query, you can say, okay, I want the ID and the name of the users, and I'm only getting that. And how awesome would it be if we could have this thing typed in TypeScript, if the return type of this would be typed. So that was the dream API, but we had no idea if this is even possible. The only thing we heard about was that there is this thing of conditional types and map types, but we had basically no idea where if this even could work or anything like that. So I went on a journey last year, and that was in February, where I was looking into, okay, is this even possible? So I went down 1 week just looking into these types. And you have to imagine back then there was not a lot of documentation around it, and there were mostly very simple examples for the conditional types and map types, but not really like more complex examples what we needed. And we were not aware of anyone else going for this approach that we are looking into. So in order to understand what we are, how we can do this, we need to understand the types. So conditional types are basically a ternary statement on a type system level. So you can say, I have some type T, it can be anything, and if it is a string, then return true, otherwise return false. That's a conditional type. It's basically an if statement for the compiler. And you can also have map types. As the name says, you can map a type. You take a type that you already have and you map it to something else. So in this example, we have an object type that we can loop through. And in this syntax here, we are having this in and key off. These are two important things to understand. The in means it's basically like a for in loop in JavaScript. That means we're looping through the properties of an object, and not an object, but an object type. And here we have the key off, so we get a list basically of the keys of the object type. Then we have this minus question mark syntax here. That is a specific syntax in TypeScript that makes all properties required, no matter if they are all, optional or not. So this is like a utility type we can now use in our code if we want to. Good, but the question is, how can we combine these? And the central question that we need to ask ourselves in order to answer the question how we can combine is, how can we find out if an object type has a property or not? That's the central question we need to ask. Because in this input, here we are calling this function find many. We want to find out, is there the ID property provided in this inline object here or not? If it is provided, we also want to put that into the return type. If not, not. So this is a question we need to be able to answer. How? How can we answer that? I found two ways for that. We can either say extends key off or extends a handcrafted type, and I will explain now what that is. Extends key off. So let's say we have this type called user args, and we say that our T, which can be anything, this generic type can be anything, that has to extend user args, but we don't know if it has the select or the take in there. So what we say does select the string literal, does the string literal select extend the key of T. So in other words, is select within the keys, right? And this is again then giving us the true or the false. That's the one option we saw. The other option is using a handcrafted type. For example, if I really want to know if the property is there in this type that I'm looking at, at this T, then I can create like a handcrafted manual type basically that has the select statement, the select property required. And then we can again say if it's extending this, then the property must be there. So we can use that to find this out. These are the two ways, but now is the question, how does that actually work? And we will look now into the actual an actual example implementation here. So here we combined the conditional types with the map types, and we have some function declaration, and this declaration should return us the right return type. So what we're doing here, again, we have a map type, we're looping through the keys of T, and then we say something very simple here. We have a condition, does key K extend the key of user? If that is the case, then just return this user key, otherwise never. So now let's call the API. We would imagine the API to be called like this with an inline object. So we have the ID here and then true. And let's see, yeah, the type is correctly inferred. We now have the user ID in here, which is a number. So the number is correctly inferred. However, there's a problem. That is, you can cast this type. You can have an object here, and you can cast it to the more general type, the user select type here. And then this does not work out anymore. Suddenly, although we know the ID is definitely there and there's definitely not the name, the types don't know that anymore. They cannot, because we are talking about the type level, not the value level. So this is not really optimal. And at Prisma, back then we didn't have an answer for this. And now you need to make a product decision. Do I move forward with this? Because this API is really nice. You can just type things in here. You can say name true, and you have that type properly. That's a really nice API to use, but it's not really type safe. So now you need to make a decision. And actually in the TypeScript repo, I created an issue, and someone also explained what the problem is here. The types in the compile time and in runtime, they don't match. So that's the problem here. And we decided at Prisma we will go for it for now. We will roll with it, and rather said, okay, this is something we need to document, that people should not use the API like that. My TypeScript heart was hurting a bit, and I knew it was not the really proper solution, but we said, okay, let's roll with it for now. We can look into that maybe later. Good. So what we did then in June 2019, we could release this in preview. And this preview, I can already show you how that actually looks like. So we implemented it. And so this is the API. With Prisma, you get a schema that defines your data model, where you say, I have a user that is related to post, etc. And what happens is then we generate JavaScript and TypeScript based on this schema. And we are now using this generated code. So for example, there's now a user available, and we can query for multiple users. So we get the user type back. However, if I, for example, say I'm not interested in the whole user, I'm just interested in the ID, I can override that, and I can say, instead of getting the whole user, just the ID, and there we go. So we see it's directly typed just while we are typing basically. And we can also say, I'm also interested in the posts of the user, so we can query a relation, and there you go, the types are updated properly. And again, for a post, we could also say, I'm just interested in the ID of the posts, and there you go, again, we have that. So this way we can, in a natural manner, write type safe, like we have auto-completion, everything here, all of this developer experience we have here, while the resulting return type is typed by this more advanced type inference. And this more advanced type inference, you may now ask, okay, how does it actually look like? So this is how it looks like. This is really complex, I know, and I cannot dive into the details today here. But after all, it's really just a combination of conditional types and map types. Awesome. So we just saw the basic API works. This is awesome. And now it's March 2020, and we said it's time to launch this in production and tell users, hey, you can now really use this in production, and this is awesome. In order to do that, it makes sense to try it out with real-world applications. So a company from SF gave us access to their schema that had 350 models and about 5,000 fields. And again, we're generating a client. We're generating out all the CRUD operations, which probably creates a lot of code. So what did it do? Just generating it took 26 seconds. Running TS node on it 25 seconds and TSC-D 42 seconds with this specific schema. With small schemas, it was not an issue. You were in less than a second or a second area, but this is obviously not the developer experience we're looking for. So I dove into it and I looked into it. How can we make this faster? So one big problem here was definitely we were just generating a lot of lines of code, 560,000 lines of code, just the declarations, and the JavaScript file was also huge. So obviously Node and TS Node, they don't do anything wrong, but they just need to parse a huge file here. So what can we do about this? So again, we have two ways how to find out if an object type has a property. This is a central thing to our type implementation. We need to find that out. And what we used to do is we said we create like a handcrafted type. So turned out the handcrafted types work better than the other method with keyoff. So we used that method as much as possible. And these handcrafted types, we had specific types for each input. So for user input, for post input, etc. Because we thought that is necessary. It turned out that's not necessary. It turned out we can just have a dummy type that has just a property select. It can even be any. And we can use that to find out if that type then has the property by just saying extends and then the has select type, for example. So it turned out we can just simplify things a lot and we don't need to create all of these different variations. And like that, we could reduce the TypeScript declarations to 309,000 lines. That is at least something. It's not yet perfect, it's just a lot, but if you have a schema with 5,000 fields, it is just big. Next stop, the generation was still quite slow, 26 seconds. How can we speed it up? So what we did is in memory, we were generating an index.ts file of that Prisma Client implementation that is specific to your schema. And we were using the programmatic TypeScript compiler API to then spit out the index.ts and the index.js. And obviously we're asking for a lot here from the TypeScript compiler. We're asking it to compile like multiple 100,000 of lines in this extreme schema. For a normal schema, it's like 5,000 lines maybe. But still, this is really, we're asking a lot. And obviously that takes time. So as we know already what we are going to generate and we have control over the code anyway, we just said we can just directly generate the DTS and the JS. And that's what we did. And as you can imagine, that sped things up. So from 26 seconds, we got down to 4.5 seconds to generate the client. And suddenly we are talking about something that is kind of okay to iterate on it. Maybe you need to change something in the schema and you need to regenerate the code. That's kind of okay, kind of acceptable. Last stop is although starting the script. And that still took really long. Why is that? We had a lot of JavaScript, 25 megabytes. And yeah, parsing that alone, the V8 compiler is awesome, but just parsing sheer amount of 25 megabytes takes a lot of time. So we looked into how can we reduce that as well. So how did we even do that? So the whole implementation of the JavaScript client was completely generated out. That means we had, for example, the update method, we had the delete many method, all of these methods, the whole implementation was generated out. And you could naively assume, yeah, this makes sense, like generating it completely out, because then it just needs to be parsed and the client is directly available. That was my intuition in the beginning. It turned out that intuition was completely wrong. And just dynamically bootstrapping that client, basically generating the implementation in runtime, is much faster. And there we're talking about 1-digit milliseconds for even this huge schema, and we're talking about less than a millisecond, so microseconds about small schemas, bootstrapping it. That was a clear learning here, and we could reduce the lines significantly. So again, we could get a big speed up here from 24 seconds to run the TS Node script to 3.5 seconds, which is kind of already getting in some direction that we can actually work on this. Good. So to summarize, we had 3 optimizations here. We removed the unnecessary utility types. We directly generate the index.js and the index.ts, and we are not generating out the whole JavaScript implementation anymore, but rather we are bootstrapping it in runtime. Good. So that's great. However, I just could not deny it. We were still not really type safe. That was still this thing. And you can push it away, but it doesn't work. I mean, this thing is still not really type safe, so I had to look into it. It was not, it's interestingly enough, it was not really an issue in practice. So people did not really hit this case a lot. I think very rare we got issues about that. But still, my TypeScript heart was like, nah, we need to look into this. This is not proper. So the last journey begins, the actual type safety. What was the actual problem here? So again, the problem was that we had a discrepancy between the runtime and the compile time. So concretely, because you could have optional properties, we were just looking, is the property there? But it could be an optional property. So we don't know if it's there. We only know it, yeah, it may exist. And that's actually the problem. The optionality of it, as the name already says, optional means it can be there but doesn't have to. So we don't have the guarantee that it's there. So what we need is required properties. So it would be awesome if on a type system level we could now say, only the required properties is what we want. Is something like that possible? Then we could solve the situation and build our types, our API around that. Is that possible? The answer is yes. And this is the solution. I have to say I did not come up with the solution. I found it somewhere in the TypeScript community. But this is a genius solution, and this actually saves the day here and makes us fully type safe. And I will now go into depth what this means. You may just think, what? What is this? And we now take some time to really go into depth what it means. Let's dissect it. So this utility type, by the way, gives you the required keys of a object type. What does that mean? If I have a couple of properties in an object type, some properties might be optional, some required. Only the required properties and their keys are returned by this utility type. So how does it work? Again, we have a map type part here. So we are again looping through the keys of the type T that we're looking into. And we again have our minus question mark, the same as we had earlier with the required utility type. That means we are making sure everything that is returned by this type are only required properties. However, we need to filter out the optional properties. And that's the next part. So this one you need to let sink in a bit. What does it mean? The empty object, or it's a question that we're asking here. That's also why there's a question mark. Does the empty object extend pick t of k? What is pick t of k? Pick t and k is basically creating a new mini type. What does it do? So k is the current key we're looking into. We're looping through all the keys. What it does, it takes that specific property out of t and creates a mini object type that just has that property. So an example, let's say we are looking into a property that is ID, that is optional and has the optional value Boolean. So optional type Boolean. So we could now say we are selecting this out. And now comes the interesting check. We say, does the empty object extend it or not? So we can ask that question. We can, for example, say I would have a variable that has the empty type, that is just an empty object, and I now want to type it with this type. I want to assign this type to it. Does that work? In this case, I would say yes, because it's an optional property. It doesn't have to be there. So the empty type is a correct instantiation of that type. In that case, in our ternary statement, we return never. Never basically means skip it, throw it out. We don't want to see it later in our types. And now let's take an example with a required property. In this case, we are taking this required property and say it's required. So an empty object is not valid. It's not a valid instantiation. So this ternary statement goes to the second option and gives us the key. So this way, we now found a way on the type system level to differentiate between optional and required properties. We just needed some way to do that. And now we can continue building our TypeSafe API. So here's just an example. We have 1 optional and 2 required properties of this object type. And this would now return this list of the keys that are required. This thing is a new powerful tool in our tool belt. And let's see how this actually works. So we had the earlier example that didn't work out as we wanted it. So again, we got this undefined stuff, but we want the guarantee that certain data is there on a type system level already. And so let's look into this one now. So what I did, I took our required keys, new favorite utility type, and instead of returning never, I just put in a type system error message. This is just an example how you can deal with this now. So we can now put in an actual error message and we can say, read more in the docs, don't do this, blah, blah, blah. So concretely, as soon as we find an optional property, we don't want that. We don't want anyone to use the API like that. So we can handle this now. And in our function here that returns the data, we can now say, okay, optionality error, if that is part of these keys here, we assign that here to this the keys to this type variable u. If that is extending this, if it's basically in that list, then just return that error and that's it. And here, otherwise, we're just going with our usual map types as we had them before. Okay, so let's look into the API. This is working. And now we come to the other example. What will actually happen here? It will give us the error. And it will let us know, please use the object inline, pass it in directly instead of typing it outside. So we now found a way to deal with this. This is just an example how you can deal with it. Prisma is dealing with it a bit different, but this is now giving us the possibility to actually act on it on a type system level. Good. I want to summarize. So we saw that we can combine conditional types and map types together, and that together they are really powerful. This is a fairly new pattern. We at least haven't seen too many people using it yet. It has been picked up recently in the GraphQL ecosystem. There are 2 clients that make it possible to generate, based on your GraphQL schema, this TypeSafe API. One is called GraphQL Zeus, the other one GenQL. And yeah, I really want to encourage you to not only look into this particular pattern, but also just look more into conditional and map types. They are really powerful. I think they are also very interesting for libraries in general. Especially for TypeScript beginners, they probably don't want to throw them around too much, but being able to do that in a library and hiding the complexity there and having readable, maintainable application code is really beautiful. And something I really have to say here now. So again, last year we were not sure if this is even possible in TypeScript, and also if this even makes sense that we want to do here. And it turns out it is possible in TypeScript. And there are a couple of people who say always bet on JavaScript because the V8 compiler got smarter and it got faster. But I think it's time to change the statement to always bet on TypeScript. Thank you.